Welcome back, everyone. Today we're going to be covering the Pythagorean theorem. So, the Pythagorean theorem is used for right triangles. It can only be used on right triangles. So, if it's a right triangle, then that means the Pythagorean theorem, you can use Pythagorean theorem, which is a squared plus b squared equals c squared. So, this side squared plus this side squared is equal to the hypotenuse squared. So there's some common Pythagorean triples that are, if you memorize those, so then you don't have to do all the work, which are 3, 4, 5. So 3, 4, and 5. The larger number always has to be the hypotenuse. Then we have 8, 15, 17, 5, 12, 13, 7, 24, 25. There's a lot more, but those are the most common ones. So first we're going to start with this triangle right here, and we're going to apply the Pythagorean theorem to find x. So a squared plus b squared equals c squared. So our a is going to be this one, this is going to be our b, this is our c. So we're going to do 6 squared plus 15 squared is equal to x squared, which you get 36 plus 225 equals x squared, which means x squared equals 261. So x is just equal to the square root of 261. Then we can also use this one. So this is our a, b, and c. So we're going to do x squared plus 9 squared equals 11 squared. So you get x squared plus 81 equals 121. Subtract 81 to the other side. X squared equals 40. So x is equal to the square root of 40. So you can use Pythagorean theorem to determine what type of triangle it is as well. So if you do a squared plus b squared equals c squared, and they equal each other, so like a squared plus b squared is that if it's equal to c squared, then it's a right triangle. If a squared plus b squared is less than c squared, then it's an obtuse triangle. And if it's greater than c squared, then it's an acute triangle. So there are also some special right triangles. So those are the 45, 45, 90 triangles and 30, 60, 90. So if it's a 45, 45, 90, that means two of the angles are 45 and the other one's 90. So that means these two legs of the triangle are equal to x, and the hypotenuse is always going to be equal to x times root 2. So we can use that over here for an example. So we have, this is a 45, 45, 90, since it's 45, 45, 90. And we're trying to find x. So this side, using this over here, this will be equal to x root 2. So we already have the root 2's, so that means x has to equal 5. So that means these two sides, that means x equals 5. Our other triangle, the 30, 60, 90, means one angle is 30 and one is 60 and the other is 90. So the side that has the 60-degree angle is going to be equal to x. The side with the 30-degree angle is equal to x root 3, and the hypotenuse is equal to 2x. So over here, we're trying to find x and y. And this was a 30, 60, 90. So, we know this side over here has to equal x root 3. So that means 12 equals x root 3. And we're trying to find x first. So we're going to divide both sides by root 3. So you have x equals 12 root 3. To get the square root out of the denominator, you can multiply by root 3 over root 3, because it's the same thing as 1. So your x equals 12 root 3 over 3, which is the same thing as 4 root 3. So that's what x equals. But now we have to find y. So going over here, our y must be equal to 2 times x. So that means that y has to be equal to 2 times 4 root 3, which is equal to 8 root 3. So that's our y. Then last we're going to cover some trigonometry. There's more than just sine, cosine, and tangent, but those are the three we're going to cover. So sine is when you can use trigonometry if there's a right angle. So sine is when you take the opposite side over the hypotenuse. So if we do sine for p, it would be the opposite side, so 15 over the hypotenuse, which is 17. Cosine is the adjacent side, so the side next to the angle over the hypotenuse. And then tangent, if we're still using p, it's going to be the opposite side over the adjacent side. So we're going to do some examples. So we're going to start with sine of p. So this is p, so sine, remember, is opposite over hypotenuse. So the opposite is 15, hypotenuse is 17. So you get 15 over 17. Now we're going to do the tangent, which is opposite over adjacent. So we have 15 over 8. So that's our tangent. Now we're moving to Q, so cosine of Q, which is cosine's adjacent over hypotenuse. So it's going to be 15 over 17. So now cosine of P is going to be 8 over 17. Sine of Q, which is the opposite over hypotenuse, which is 8 over 17. And then lastly, we have tangent of Q, which is 8 over 15. Okay, that's it for today, but as always, if you have questions, feel free to leave them in the comments and I'll be happy to answer them for you. Bye!